Can someone run at the same speed forever? When you start running, are you instantly at your top speed, or do you need to warm up and accelerate? So we're going to be learning how to calculate acceleration. First, let's look at the definition. What is acceleration? Acceleration is the change in velocity over time. Makes perfect sense, right? You know every word in that definition. If you don't, you may notice velocity and go, what the heck is that? This video will help you. So what is velocity? Velocity is the speed of an object and its direction of motion. It's the speed and direction. Velocity is measured in meters per second, just like speed. This is on page 18 of your notes, by the way. So it's the same thing as speed, except it also has a direction involved with it. If a problem asks you to calculate velocity, use the equation for speed, which is distance over time, and include the direction it's moving in. So velocity versus speed. What do we already know? We know that speed is how fast an object moves. And when you calculate for speed, your answer looks a lot like this: 25 meters per second. Velocity is how fast an object moves and its direction. So your answer is going to look like this: the car was moving at 25 meters per second north. Two objects have different velocities if their speed and/or direction is different. So for example, two runners can have different velocities if they're running in the same direction but at different speeds. So these two runners are both running west, but this runner is a little bit faster than the runner behind him. You could also have different velocities if two runners are running in different directions at the same speed. So they're both running at 5 meters per second, but this runner is running west and this runner is running east, totally opposite from each other. Because the different direction is there, they have a different velocity. Two runners could also have different velocities if they're running in different directions at different speeds. So everything is different about this picture. You have different directions, west versus east, and this runner is still a little bit faster than this runner. So velocity includes speed and direction. So let's go back to acceleration. All right, so a reminder, acceleration is the change in velocity over time. Now, acceleration is measured in meters per second squared, or for a shorter version, m/s2. Acceleration can be positive or negative. A positive acceleration means the object is speeding up. That's usually how we use the term accelerate. A negative acceleration means the object is slowing down. So negative acceleration is also called deceleration. You can use whatever term you feel more comfortable with. Positive is speeding up, negative is slowing down. And this is on page 23 in your notes. We kind of jumped around. So how do we calculate for acceleration? Well, acceleration is change in velocity divided by time. But what does change in velocity mean? Well, that change in velocity is basically your ending speed minus your starting speed. And the way we write that, so you don't have to write the whole two words, you'll see VI and VF. So V standing for velocity, I stands for initial. So your initial velocity or your starting speed. Your ending speed is V for velocity and F for final, your final velocity. So to find acceleration, you need to know these things. You need to know what is the final velocity or the ending speed, what's the initial velocity or the starting speed, and what is the time they're giving me. Now here are some tips for the word problems you'll see in the future. So if the word problem contains the phrase if an object starts or stops at rest, it means the velocity is 0. Other phrases that can tell you velocity is 0 include it takes off, or the car comes to a stop, or anything that really tells you motion is starting or stopping. That means velocity is either starting at 0 or it's ending at 0. So let's do some practice problems. So a skier takes off from the top of a ski run and reaches a velocity of 24 meters per second after 4 seconds. What is a skier's acceleration? Here's my equation. Acceleration equals final velocity minus initial velocity divided by time. So my final velocity is 24 meters per second minus my initial velocity, which was 0 because I was just kind of staying there on top of the mountain before we took off. And then it's divided by time, which was 4 seconds. Now these parentheses are really important because that means you have to do this top equation first, take that number, and then divide it by time. If you put this right into your phone calculator or whatever calculator you're using without the parentheses, you might get a wrong answer. So we don't really have to use the calculator for this top one, right? 24 minus 0 is 24. Divided by 4 is 6 meters per second square. Let's find the deceleration or negative acceleration. So a child on a skateboard is traveling at a velocity of 8 meters per second. At the bottom of the hill, he slows down and comes to a stop in 4 seconds. What's the deceleration? We're using the same equation. So take some time and try and solve that on your own. So the final velocity, since he slows down and comes to a stop, is 0. His initial velocity was 8 meters per second. And the time that's given us is 4 seconds. So 0 minus 8 is negative 8 divided by 4 equals negative 2 meters squared. So because he was decelerating or he has a negative acceleration, the answer is negative. Makes sense. Let's try and find time, right? Because our speed equation, we were able to find all of the different units some way. Let's try and find time. So a skydiver jumps out of a plane. She has an acceleration of 9.8 meters per second squared as she falls to the earth. How many seconds will it take to reach a speed of 28.5 meters per second? So we're looking for time. So I'm going to rearrange the equation for you so you don't have to. So time equals, again, the change in velocity, but this time it's going to be over acceleration or divided by acceleration. So take some time and pause the video to try it yourself. So our equation should look like this. Our final velocity was 28.5 meters per second, right? How many seconds will it take to reach a speed? And our starting speed or initial velocity was 0 before she even jumped out and was falling. It was just 0. So her acceleration was 9.8. So once you calculate it, you should come up to 2.91 seconds. That's how many seconds it'll take for her to reach a speed of 28.5 meters per second.